everyone. Is this working? Can you hear me through the microphone? Awesome. Good morning. It's great to be back, this time at this colorful venue. I really like the Tetris pieces. Like it really gives some color to the event. I've been attending this event, participating in this event since 2016. And so what I thought to do this year is actually, given that I've been presenting some projects and ideas in other years, what about if I do kind of like a recap, an update, and then present something new after? So who was here in 2016? Just quick show of hands. All right, yeah, I remember seeing your faces, that's true. So 2016 was when I got the chance to introduce to this community the Ipfs Project, a project to distribute the web. And the web, as we know, has many issues today, or the model that we have for the web today has many issues. It doesn't work in disconnected scenarios. It doesn't work offline, like links break all the time. The security model is not great. It's getting kicked out of IoT, and then there's also like all these censorship issues that we keep seeing happening all over the world more and more often. And so Ipfs, a protocol to make the web distributed, is a protocol to upgrade the web, to make it faster, more secure, to work offline, safer. And the keyword here is really the upgrade. Like we, as the Ipfs project creators, we intended from the beginning to make sure that Ipfs could integrate with the current web model and have a clear migration path that would enable browsers, users, application services to level up their services as time progresses. It's not an alternative web. There have been many attempts in the past to create a better solution for the web. The reality is like shifting everyone from one web to another web is almost impossible. And so upgradability is essential for future-proofing. And the way that Ipfs does this is really by changing one simple design on the way that the web works, which is moving from a location-addressed web to a content-addressed web. What this means is, instead of like you looking for a piece of information that is available in some machine online, you actually look for the cryptographic fingerprint, the content hash. And so instead of like you having to go to some location, you can just ask around. Like you can ask the network who has this content, and then anyone in the network can give that content to you. You don't have to rely on a central point of authority, because you, as a user, you can verify that you receive that content. So I will not dive deep into Ipfs details. You can see that presentation from 2016, which TADSummit generously puts available online. But yeah, what has happened since then? So in terms of releases, the reference implementations Go and JS had over 80 releases with many features, many bug fixes, many performance improvements. We created a page for the JavaScript implementation. You can visit today js.ipfs.io. And this page has a very special feature, which is it can transform your browser into an Ipfs gateway. So it uses an Ipfs node running in JavaScript, no plugins added, and it installs a service worker. And so every time you use it to fetch some piece of information from the Ipfs network, your browser will catch that request, connect to the Ipfs network, fetch the content, and serve it to you. So effectively, it is using HTTP to present you the content, because that's the way that the browser expects the content to come, but it's using the Ipfs network, so it's not doing HTTP calls to a server to fetch the content. It is directly through the Ipfs network. And so other things that we created and released is the Ipfs cluster project. So many people started running their own pinning services, and a pinning service is making sure that the copies of the content are available on the network at all times. And so one big demand was, can we have a tool that help us orchestrate multiple Ipfs nodes that can be distributed all over the world? This is today open to everyone, and many of these pinning services are using it. Other things that we released was we revamped the Ipfs UI, so now it's easier than ever to for the everyday user to understand what this Ipfs node is doing, from bandwidth usage, connections that it creates, and you can use it to explore the data that exists on Ipfs network as well. We also created a desktop application so that you can get that really nice convenient feature of like drag and dropping a file and just getting it to the Ipfs network, get the content address, and share it with your friends. And then the Ipfs browser extension, Ipfs Companion, has been paving the path for browsers to go from the web platform to the DWeb platform. What this translates to is a lot of growth. So we now see applications, really like professional, mature applications appearing from all the places. We have from things like social networks, we have streaming services, we have marketplaces, we have collaborative doc editors, we have even like mixed reality applications that use IPFS to distribute the assets, because when you are dealing with mixed reality, the assets are kind of huge, so having a peer-to-peer network is useful. We see photo sharing applications and applications that put at its core making sure that the files are private and that only the users that have access to those files actually have access to them. And then there's like many other orgs that are adopting IPFS to archive data, to establish collaboration between multiple organizations, to have the conversation of like who possesses which data, and so on. And so this has been super explosive, and we created a webpage that you can consult. It's available at awesome.ipfs.io, and it's a webpage that is community-driven, so anyone can add items to this list. And it lists like applications, articles, data sets, tools, and many videos. So this is like everything that the community is producing is kind of like listed here if someone from the community adds it to the list. So it's a very good way to check all the activity that is happening. We also created a documentation portal. This was like a big ask from the community. How does this thing works? And so now it's available. We have an IPFS community of meetups. So these are meetups all over the world that keep popping up from all over the place, and they are community driven. So someone that really cares about distributing the web is organizing an event for the local community. We started a translation project, and we now have many of our websites, many of our documentations available in available in 22 languages. And this is like super powerful because first, this is the community coming and saying, hey, I think this project is important for my community, and it's important for them to have access to this documentation in their own language. So they contribute with the translation. I personally believe that knowledge, one of the biggest barriers for knowledge transfer today is still the language, because a lot of people don't have, we assume that like everyone can use Google Translate for everything, but like when you go into technical stuff, you really need to have some kind of bridge or some kind of documentation in your own language to understand it well. And also another very exciting update, Cloudflare, one of the largest CDNs in the world, decided to go interplanetary. So now Cloudflare is hosting their own IPFS nodes, their own IPFS gateways, and helping users put their websites on IPFS. And so that users can have their websites, their web applications served by this peer-to-peer network. So there is even more. What about browsers? So last year, we showed that it was possible to run an IPFS node inside the browser, and with it, grant the browser new superpowers. So this is the Brave browser, and like it has an IPFS node running inside it, and with it, we can load content from the IPFS network. This year, Firefox announced support for the centralization protocol. So they added support for the protocol handlers of like IPFS and DWeb to the browser so that we can create handlers to listen on these protocols and answer to those requests. This is also coming soon to Chromium. To even push more for this momentum, we created a webpage called Are We Distributed Yet? And this webpage lists all of the shortcomings that we have identified with the rest of the community that like block us from making the experience on the browser really, really nice. And the unimaginable happened, right? Mozilla paid attention, and they decided to create an extension called libdweb that you can ship with your Firefox nightly version. And this libdweb gives the browser new capabilities, new properties. For example, making access to the file system, or access to UDP sockets, or TCP sockets, or even like multicast DNS. Having access to these capabilities enables us, builders of the DWeb, to create very exciting demos that we also have published them online and show the potential of what would be a browser with these kind of protocols with like the full extent of their features. And so this is like unprecedented, right? If 2 years ago you asked me, oh, will we ever convince the browser vendors to implement these protocols, I would probably I'll be optimistic and say yes, but I know that like, it is so hard. And I think this community understands that very well. If you played with WebRTC and like all of the multiple year conversations around WebRTC and how to deploy that to the browsers and how to reach consensus, it is something that is hard because again, the web platform is used by pretty much everyone that has access to the internet. And so this was very exciting that Mozilla paid attention and like is enabling us to show the power of these protocols on the web platform. If this is a lot of stuff and you feel like, wow, like there's so many things happening and it's so hard to understand, like to just like understand what is happening and like where the project is headed, we hear you and we got you. Like we are shipping this quarter an updated version of the Ipfs Project roadmap. Right now, this is the work in progress document. It will be available on GitHub and it will be available by the end of this quarter. Another exciting thing is if you are more a person of like going to events and like listening to talks, then we also have news for you because you can come to Lisbon again next year for the first Ipfs conference. So this is going to be super exciting to get all the community together here in Lisbon, an amazing city to organize events. And yeah, so we are super excited about that. That was 2016. Let's go to 2017. Who was here in 2017? All right. Cool, great to see you again. So 2017, I basically talked about two things. One, a research lab, a new generation research lab that focuses on moving ideas through the research pipeline from ideas to specs to code to computers to humans and grant humans new superpowers. In this research lab, Protocol Labs, is kind of like a stellar nursery, or at least we like to call it a stellar nursery for foundational infrastructure. We focus really hard on like identifying problems and creating projects that get their own gravity, that they become their own stars, and like support the project until they can sustain itself, become its own thing, and then like go to the next challenge. We have many projects, Ipfs, Falcone, IPLD, peer-to-peer multi-formats, and others. And one of them that, again, I talked last year was Falcone. So Falcone is this decentralized storage market for retrieval and for storage. And it enables users to harness the latent storage that is available in the world and have a market where they can trade the storage that is available. So imagine like all of your laptops, all of your computers, all of your data centers, if you have one, you can like put that storage available to the market, and instead of going through the normal pipeline of like hiring storage from some cloud provider, you can hire that storage from anyone in the world. So this is like has a huge potential, especially for emerging communities, emerging markets, because you can be a local entrepreneur, hook up some hard drives, and suddenly like those services that are providing video or kinds of content, they can pay you to get that content very close to the users so that new users, new clients appear. Okay, so kind of like quick recap from 2017 to now. Protocol Labs Research, we announced the Protocol Labs Research Grant Program. And we here market with a $5 million research program. So far, we have handed out $400,000 in grants. And the themes that we have been funding are from open source funding, how to fund open source, novel proofs, proofs of replication, CRDTs, energy grids, semantic data, and more. There is many academic publications, and not only. And we also have been sponsoring academic conferences all over the world. One of the things that we are really happy about is that we supported and sponsored the creation of the Stanford Center for Blockchain Research. So we are one of the sponsors. There are many others. On Filecoin, we have launched an update 3 months ago of like the state of development. Totally recommend everyone to check out. What it includes is demos from the Falcone implementation and testnet simulator. It has a demo of like how to visualize the network and see the activity of the network. And also shows how the storage market works so that you can have a clear idea of how these things work in practice. And one of the things that is on that update is the Falcone project roadmap. We are now in this stage where we got the Go Falcone implementation. We expect to have many other implementations, but we decided to focus with Go. And we want to launch the Falcone testnet for all of the miners that's registered for the program in advance in early 2019. And by mid-late 2019, we want to launch the Falcone main network. So this is super exciting. Okay, so now we arrive at 2018. I have more or less 5 minutes, right? Okay. Yeah, okay. 5 minutes, I think it will be enough. Cool, okay, so what are the things for 2018? 2018 seems to be like the year of the Web 3.0, or at least like we keep hearing this term appearing all over the place. And it is not a new term, right? Like if you have been on this field for a while, you have definitely heard about Web 3.0 before. But it's important to recognize that like technology comes in revolutions, and sometimes it's not the right time for technology to land. But like every time a revolution happens, users basically get new superpowers, new abilities to the things that they were not able to do before. And so why 3.0? Like what are the other versions? If we think, like if we look at the history, we have the internet first, where we kind of like figure out how to connect everyone together and how computers can connect and communicate with each other. Then we have like the Web 1.0 revolution, which is like the read only, like the static web, where people could access documents. This was more of like a document viewer. Then we have the Web 2.0, which is like a read, write dynamic web. So users could interact with the web, they could create content also to make it, put it available on the web. And then the Web 3.0, which the world is still trying to define what it really means. It's kind of like the read, write, trust, and verifiable web. It's about adding verifiability to the operations, to the actions that we are doing on this web platform. And so, again, like if you have been here for a while, this term was here before in the past with things like the semantic web, which now has been revitalized to the linked data web. Sometimes people reference blockchains as the Web 3.0, but the reality is, yes, like blockchains are a huge, important revolution in technology because they ended the peer-to-peer winter, and they showed us how markets and the right incentive mechanisms can create very powerful networks that run by themselves. But they actually are not web native, like Bitcoin and the other blockchains don't run in the browser, at least from the start. And then we have the Decentralized Web Movement, which is about moving the power to the edges, making sure that we remove the need to have decentralized points of control, which have benefits, but also a lot of problems, and really give the power back to the user. And the way that we think about it is like Web3 is all of this together. And again, it's really about verifiability. Make sure that like you can prove that like some action was executed. What this translates to is to a thing that we call open services. When you have like a service that looks like an utility that can run by itself, people can like join and leave, and because you can verify if the players, if the participants are executing the right thing at the right time with the right inputs and generating the right outputs, you can create these services that everyone can be super transparent. Let's just like think about one example. So everyone uses Wikipedia, but like not everyone understands what is the cost of running Wikipedia. And so we see Wikipedia often doing these ad hoc fundraising campaigns to make sure that the service continues to run. But like we don't have a way to really like measure what is our expenditure when we are using Wikipedia. So imagine like having a system that you could measure, you could like see how much you are spending from like just running this service and like consuming this service, and then you could like decide to pay that amount to use this service. Like you could have a way to interact with this service that you pay directly, or if a country or a company really relies on like running this service, like using this service, leveraging this service, instead of like having ad hoc ways to kind of like inject money to make sure that it runs, they could just like sponsor everyone's usage. And this can be like all public, all verifiable, like executing on some public infrastructure that is incentivized to make sure that the service runs. And so this is like super powerful, and like getting like understanding exactly how this works. It's still something that like the world is still like understanding, learning. But if you think that the revolution is not already happening, take a peek of this chart. So this is like by the Internet Foundation, Internet Blockchain Foundation, and it shows like a one-to-one mapping of many Web 2.0 services to the Web 3.0 versions. It's a very long list. And so again, Web 3.0 is about verifiability. The one thing that like all of these applications have as a challenge is one thing that I'm very excited to talk about here with this community, which is identity. So all of these applications need a sort of way to authenticate users and to authenticate these operations, like connect like a private key to an actual user. And identity is not just like a Web 3.0 issue. We just happen to fool ourselves to think that the identity systems that we have for the Web 2.0 are actually reliable and trustworthy, but they are not. Like, what does it mean to authenticate with my Google account and then suddenly give all my permissions to some service that I don't know anymore what they are doing with that authentication token? And the reason why it's so hard is it's a UX problem. How can we communicate to a user that we are authenticating another user, that we are validating their credentials, that we are granting them new capabilities to access docs, or to revoke access, to recover access, create personas, and so on. And so perhaps what you're thinking right now is, oh, I know, I just like connect to some API, and like I authenticate all the users, and like this gets registered in the database, and that's fine. Well, the reality is like not quite, right? Because like it doesn't work in a disconnected or offline scenario. Like think about all the services that you use today, and how many of them break when you go on a train, or like go on a plane, or just go to a location in the world that doesn't have good connectivity. So this is still like a big challenge to make sure that all of these operations that users are doing can be verifiable in a way that other users can trust without relying on third parties. We have been doing research and like studying all of the proposed decentralized identity systems. You can find this survey online on our GitHub. It kind of like lists the features and the shortcomings of many of these services. We grabbed all of these ideas and we kind of like made a proposal, not one more alternative, but actually one that tries to gel all of them, called the peer star identity. And the proposal from the peer star identity is quite simple. It's this like sandbox identity manager that the user controls, and then the user can, through crypto primitives, through signatures, through communication with these multiple providers, like give access to certain resources. Going very fast to make sure that I wrap up quickly. We went from the RFC, so we transpiled that RFC into code. So you can check this module Peer Star app. It has many of those ideas that are listed on RFC implemented. There's also a workshop to do app, so like you can like give it to your developers or just try it by yourself and see how these things work on the D-Web. There's also a video that walks you through. And this code is powering two applications, PeerPath, a collaborative doc editor without any centralized endpoint, and Discussify, which is a Discuss platform that you can comment on any resource that is online without needing, again, any centralized provider. And these are like blueprints for you to design your own applications, like you can follow them and implement, or you can just like fork it and create your own. And so to wrap up, if these problems are interesting to you, if these questions, if you are concerned about it, I welcome you to join the community. Like, so everything that I talked about is 100% open source. Everything is available on GitHub. We discuss a lot in IRC. And it's really important to have input from everyone on designing these architecture pieces for the internet, because the things that we decide to implement and ship are the things that are going to shape the web, the platform that everyone uses, and that they will tell, like they will describe what are the power structures of the soon future to be. So yeah, I end it here. Thank you all for your attention, and I'm happy to answer any questions if you have any.
Excellent, thank you so much, David.